Hello student, how are you? I'm Arunsir. Welcome to my channel Tuition Expert. Today in this class, I will teach you fluid mechanics complete chapter in one shot. This is the best NEET crash course series. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Fluid mechanics in one shot. First, pressure and thrust by liquid. Pressure at that point, pressure at that point, pressure at depth h equal to h This is due to liquid pressure, pressure due to liquid, pressure due to liquid. Now also atmospheric pressure acts. Now total pressure will be pressure due to liquid plus atmospheric pressure PA. Total pressure will be liquid pressure plus atmospheric pressure. Now PT minus PA. This is called absolute pressure, and this is called liquid pressure, and this is atmospheric pressure. So PT minus PA equal to PL, which is absolute pressure minus atmospheric pressure equal to pressure due to liquid. Then this pressure is called gauge pressure. So if we subtract atmospheric pressure from total pressure, then we get pressure due to liquid, and this pressure is called gauge pressure. Now PA is everywhere. If we take this point, then PA remain constant. So equal to H1 dg, that is gauge pressure depends on the depth of the point. Gauge pressure depends on the depth, gauge pressure depends on the density, and gauge pressure depends on the G. So three variables here. Pressure acts. Suppose this is a container and a liquid contains in the container. So pressure acts normally on the container wall. Pressure acts normally on container wall. Now third condition is pressure at all points along same horizontal level equal. Pressure at all points along same horizontal line are equal. So if the same horizontal line, this now pressure at this point, pressure at this point, all are equal. And pressure, thrust is force exerted by the liquid. Thrust equal to, so thrust is actually force exerted by the liquid. Force equal to pressure into area. So formula of thrust is pressure into area. Now suppose this is a cylinder shape container and liquid is contained within the cylinder. Now if thrust at bottom is equal to thrust on side pressure, side wall, relation between h greater than r. This is option 1. H is height and r is radius of the cylinder. Second option, h less than r. See, h equal to 2r, d h equal to r. Which option is correct? If thrust on the container, thrust on the bottom surface, thrust on the bottom surface is equal to thrust on the side wall, then which option is correct? So I defined that thrust equal to pressure into area. Formula of thrust is pressure into area. Now pressure, we know pressure at a depth is equal to HDG. Now if the depth is varies, then how can we calculate the pressure? So if H varies, that is depth varies, then we take average pressure. We calculate average pressure. So here pressure thrust due to side wall equal to thrust at bottom surface. So this is the condition. Now bottom surface, every point on the bottom is at same depth, so every point on the bottom is the same depth. So bottom surface thrust equal to pressure into area is pi r square. Pressure equal to HDG, where D equal to density of the liquid. Now thrust on the side wall, how we calculate thrust on the side wall? Here take 2 points, this point and this point. This point H equal to 0, and for this point H equal to H. Now so average, we calculate the average pressure from due to side surface. Average pressure equal to 0 plus here pressure is 0 and here pressure is HDG, so by 2. This is the average pressure. Average pressure into side area of side wall 2 pi r h, which is equal to HDG into pi r square. So if we calculate, we get H equal to R. So option is H equal to R. So thrust is force into thrust equal to force by the liquid. So if pressure varies, then we take the average pressure. Okay. Next, density of the liquid. Rho equal to mass by volume. We know T equal to m by v. Now density of liquid mixture. Suppose two liquids. Here mass is m1 and density is rho1 and volume is v1. In another container, liquid is present, mass is m2, density rho2 and volume v2. Now if the two liquids are mixed in a container, suppose two liquid, these mixture, what is the density of the mixture? Suppose two container contain two liquids, mass volume density are given. Here mass volume density are given. If the two liquids mixed in a container, what is the density of the mixture? So density of the mixture equal to total mass, so total mass by total volume, simple calculation. Now if m1 equal to m2, now we know density equal to mass by volume v1 and rho2 equal to mass by volume. So v1 equal to m1 by rho1. So m1 plus m2 divided by v1 equal to m1 by rho1 plus m2 equal to v2 equal to m2 by rho2. Now if m1 equal to m2, if m1 equal to m2, then we get 2 m1 rho1 rho2 by m1 rho1 plus rho2. We cancel this. So if m1 equal to m2, what is the density? Density of the mixture will be 2 rho1 rho2 by rho1 plus rho2. This is the formula. If m1 equal to empty to rho, density of the mixture equal to this. If now if volume equal, now if volume equal, then what is the formula? Rho equal to, we eliminate mass equal to rho into volume, so rho equal to, we can write rho 1 v1 plus rho 2 v2 by v1 plus v2, and putting v1 equal to v2, we get 1 plus rho 2 by 2, we get this result. If v1 equal to v2, we get problems related in problems related in U-shape container. Suppose a U-shape container is present, a liquid is present in U-shape container, and the question is, suppose a U-shape container liquid, some liquid is present first, the liquid rho 2 is present, then from one side a liquid of density rho 1 is poured in this arm, and another liquid of density rho 3 is poured in this side, in this side. Three liquids are immiscible from each other, immiscible, that is cannot mixed with each other. Now if this height of the liquid is h1 and if this height of the liquid is h2, what is the, and rho 1 rho 2 is given, rho 1 rho 2 are given, find height, find h1 h2 given, rho 1 rho 2 are given, h1 h2 are given, find the rho 3, density of the this liquid, density of this liquid, rho 1 rho 2, rho 1 rho 2 given, that is density of these are given, h1 h2 are given, what is the density of the rho 3? So to solve this type of problem, we use the principle that along horizontal same level, along horizontal line pressure will be equal. We use along same horizontal line pressure will be equal. So take 2 points, suppose A and B. This is a horizontal line, from this line below, from this line, there are same liquid, so we take velocity, we take pressure at A equal to pressure at B. So this is along this is same horizontal line, so pressure at any point of the same horizontal line equal, so we take pressure at A equal to pressure at B. Okay, pressure at A equal to pressure at B. Now what is the pressure at A? Pressure, here two liquids present, this liquid and this liquid. The height of this liquid is H2 and height of this liquid we get H1 minus H2, because this is H1, this is H2, so this height is H minus H2. So height of this liquid H1 minus H2. So there are two liquids, but what is the pressure? Pressure will be H2 rho 3 G plus, here pressure is H1 minus H2 rho, this is this liquid has density rho 2 into G. Now pressure at B, H1 rho 1 G. So from this we get the rho 3, from this we get the rho 3, this is unknown, so G cancel, and H1 H2 all are given, so rho 3 equal to this, we get this. So we use the principle that along same horizontal line pressure is equal. Now which line we select? Which line we select? The line we select below which there are same liquid. The line along which below this line there are same liquid, we select that line. Okay, so now pressure at any point, any 2 point, pressure at 2 point along same horizontal level are equal. Law and multiplication of thrust. Pascal's law and multiplication of thrust. What is Pascal's law? Pascal's law consider that within a closed liquid, if pressure is exerted, then that pressure is transmitted in all directions with undiminished magnitude. If pressure is applied at any closed liquid, then this pressure is transmitted in all directions with undiminished magnitude, and that pressure is act on the container wall normally. So this pressure will not change. This is the Pascal's law. Now you use this Pascal's law, we use the multiplication of thrust. Suppose here is a piston present and here is another piston. So these pistons are supposed contain car. This is a liquid is present. Liquid or gas may be present. Gas is a type of liquid because liquid and gas can flow. So gas is also a fluid property. Gas also has a fluid property. Suppose this is a car. This is a small piston. This weight is W1. This weight is W2. Now this area of the piston is A1 and area of the piston is A2. Now A1, A2 all are given. A1, A2, W1 are given. A1, A2, W2 are given. Find W1. What weight should be placed on this piston so that the car can lift? What weight? Find W1 so that car of weight W2 can be lifted. This is the question. So this is for multiplication of thrust law and Pascal's law. So here pressure exact is here pressure P. Now here total force W2 equal to pressure into area. Pressure we get from this W1 by A1, pressure equal to the force by area W1 by A1 into A2. So W1 equal to A1 by A2 into W2. So this is the answer. That is, to remember the formula, we remember that pressure from this piston W1 by A1 equal to pressure of this piston W2 by A2. So we remember this formula, then from this formula we can find W1. This is Pascal's law. Pressure remains same at all points. So W1 by A1 equal to W2 by A2. Archimedes principle. So what is Archimedes principle? Suppose in a liquid, this is a liquid in a container is suppose this is a cube is this is a cube is immersed within this liquid. Now this cube has side length A and this height is h and this height is h plus a. Now the thrust by the liquid act in this direction and here thrust is in this direction. So here F2 F1. So total thrust we calculate first what is upthrust, what is upthrust, and to calculate the upthrust. What is upthrust? Upthrust is net force exerted on a immersed body. Net force exerted by liquid by immersed on a immersed body. This is the upthrust. So what is upthrust? Upthrust is the net force exerted by the liquid. Net force exerted by the liquid on a immersed body is upthrust. So we calculate the upthrust. First, what is upthrust? So here upthrust equal to net force exerted by the liquid on immersed body. Okay, immersed body. So here F2 minus F1. F2 equal to what? F2 equal to pressure, H plus A, density into G. Pressure into area. Area is A square. This is pressure into area, force, minus F1 is what? F1 equal to HdG into A square, because this surface is at height H, so pressure equal to HdG, and this surface is at height H plus A, so pressure of this surface is H plus. Now upward pressure, this is downward pressure, but downward pressure and upward pressure both are equal. So here we calculate downward pressure. This pressure will be equal to the upward pressure. So upward pressure equal to this into area. Now this is the force. So we calculate A square. From this we get AQ D into G. Now what is AQ? AQ equal to volume of body into D, density of liquid into G. So volume of body into density of liquid into G, that is, what is this? AQ, because AQ equal to volume of body. So what is AQ? Volume of body, VdG. So this is the upthrust. So we get upthrust equal to also called buoyancy force. Upthrust equal to buoyancy force, which is AQ. AQ means volume of displaced liquid into D for density of liquid into G. So upthrust equal to buoyancy force, which is equal to VdG. So we remember the formula of upthrust. B equal to VdG. Remember this. Buoyancy force equal to volume into density into G. What is volume? Volume of displaced liquid. What is V? V is volume of displaced liquid. This is V. And D, density of the liquid. This is D and G. So buoyancy force equal to VdG. You remember. And the loss of weight is upthrust. Upthrust equal to buoyancy force, which is equal to denoted by B, equal to loss of weight of the body. Loss of weight of the body equal to actual weight minus apparent weight. Actual weight, that is weight in actual. What is actual weight? Actual weight is weight in air. Weight in air minus apparent weight. What is apparent weight? Weight in liquid. So upthrust equal to buoyancy force, which is loss of weight of the body, which is equal to actual weight minus apparent weight. That is weight in air minus weight in liquid of the body. And this equal to again VdG. That is V into D, that is weight of liquid displaced. Weight of liquid displaced. So these are the same things. Total buoyancy force, we can remember upthrust equal to buoyancy force. Again buoyancy force equal to weight of liquid displaced. This is loss of weight of the body. All the things are same. All this term, upthrust, buoyancy force, loss of weight of the body equal to actual weight minus apparent weight, which is equal to VdG. VdG means weight of liquid displaced. All the things are same. So you have to remember this this relation, all the terms are same, all the terms are same. Now what is the acceleration of body within liquid? Here density of the liquid be given, liquid of density, suppose rho, liquid of density, suppose rho L. Now suppose this is a container, a liquid is present within the container, and we want to calculate the acceleration of this body within the liquid. So what acceleration it moves in, with what acceleration it moves. So if the mass of the body is m, then buoyancy force act in this direction and weight act in this direction. So if the acceleration is a, then we get what is the equation? Mg minus buoyancy force equal to ma. So mg minus buoyancy force v into density of the liquid into rho L, density of the liquid g equal to mass m into a. Now what is a? A equal to g minus v by m into rho L into g. Now g into 1 minus v. What is v? V equal to mass into density. V is volume of the body. V equal to volume of the body. Volume of the body. Volume of the body equal to d equal to rho equal to mass by volume. So so v by m equal to 1 by rho s. So rho L by rho s into this. So this is the answer. Acceleration of the body within the liquid equal to 1 minus rho L by rho s. Rho L is, what is rho L? Rho L is density of liquid. Density of liquid, and rho s is density of solid. Density of solid. Okay. Now you can, to solve this problem, you can remember this formula. You can remember this formula, or if you cannot remember, then use this equation to find the acceleration of the immersed body, acceleration of the immersed body, acceleration of the immersed body within a liquid. We use this equation. So what is the problem? Problem is here. Suppose this is given 1 by 4. This is given 1 by 4. Density of the cork to the density of the liquid is 1 by 4. Now this height is h given. So what is the time taken? T equal to what? To find the time taken, we use the equation h equal to 0t plus half a into t square. What is a? A equal to acceleration of the cork within the liquid. Now we use this formula, acceleration equal to, here it moves upward, so g into density of the liquid dl by ds minus 1. Now what is dl by ds? Dl by ds equal to 4. So g into 4 minus 1, that is 3g. So 3g. So we use a equal to 3g. So t equal to 2h by a root over, which is 2h by, which is 2h 2h by a equal to what? A equal to, we get 3g. The condition of flotation. Condition of flotation. So what is the condition? Condition of flotation is weight of the body is equal to, weight of the body is equal to buoyancy force. Weight of the body equal to buoyancy force. This is the condition of flotation. This is the condition of flotation. Weight of the body equal to buoyancy force. So problem comes from this condition of flotation, b equal to mg, and the apparent weight of floating body, apparent weight equal to real weight minus buoyancy force. If b equal to mg, then we get, so apparent weight of the floating body is 0. Apparent weight of the floating body is 0. It is d1. Density of the liquid is d1. When this block is fluids, when this block fluids within this liquid, then it's 30% upside and 70% within the liquid. And if the same block is fluids with another liquid. Suppose this is the density of the liquid is d2, and another liquid, now its 20% is upside, 20% is upside. So if these are same block, if the same block floats within this liquid, then 20% is upside the liquid. So what is the ratio of d2 by d1? d2 by d1 equal to what? So how we solve this problem? Same block, same, this is suppose wooden block. To solve this problem, we use the same block condition of flotation. This block floats within the liquid. When there is condition that floats, when this term is used in the problem, then we use the condition of flotation. So condition of flotation equal to mg equal to buoyancy force. Suppose here buoyancy force is b1 and weight mg act through the center. Weight act in the center, and here buoyancy force act in the middle of this liquid. Buoyancy force act through the center, that is center of buoyancy is within middle of the liquid portion, middle of this portion, and weight act middle of this wooden block, So mg equal to b1, what is b1 equal, suppose volume of this block is b, it's 30% upside, that means it's 70% inside. So buoyancy force equal to volume of the displaced liquid 70 by 100 of v into density of the liquid d1 into g. This is the condition. Now here equal to mg equal to same block, so mg equal to b2, now b2, what is b2? b2 here 20% upside means 80% inside, so 80 by 100 into v into density of d2 into g. So we get here d2 by d1 equal to 7 by 8. So this is the answer. Okay, this is the answer. Container contains some liquid, and a sphere, a cell, suppose this is a cell, this thickness is t, now density of the cell is rho, and this is r, radius of the cell is r, so density of the cell is rho. Now what is the condition of the density of the material, so that it can float? So find value of rho if density of the liquid is rho L given. Suppose density of the liquid, this is density of liquid, given, find value of rho, density of the cell, solid or material of the cell, find value of rho m for which it can floats. So what is the condition? The condition is buoyancy force equal to mg. Now buoyancy force equal to volume v into density of the liquid rho L, g equal to mass g cancel. Now what is volume? Volume of the outside. So volume of the outside volume of the cell we consider here outside, because the the cell displaces the liquid equal to its volume. The cell displaces the liquid equal to the volume of this outside, so volume of the displaced liquid will be volume of the cell. Now what is the volume? Volume equal to, what is the volume? Volume equal to volume outside volume equal to what? 4/3 pi r cube into density of the liquid rho L into g. Now what is the mass of this material? Now mass equal to volume of this part, 4/3 pi r cube minus 4/3 pi r minus t whole cube into g. G cancel. So this into density of the material rho m. So rho m equal to this by this. So rho m equal to density of the material equal to this by this, that is rho L by 4/3 pi cancel minus r minus r minus t whole cube. 4/3 pi 4/3 pi cancel r cube into this. So rho m equal to this. Now if we divide it by r cube, we get this. Now t by r less than 1. So we neglect the higher power. That is t by r square, and t by rq is almost to 0. So we neglect the higher power. We get this equal to rho l on 3t by r by 3t. So this is the answer. R t all are given. So this is the answer. If rho m greater than equal to this, rho m less than equal to this, rho m density of the material less than equal to this, then it can fluids. And for this is the, if this value is just exact equal to this value, then it just can fluid. And if the value is less than this, then it can move up. And if this value is greater than this value, then it moves downward. So this is the exact value for which it can just fluid. This is the exact value. Now in this diagram, the whole system is in equilibrium. Whole system is in equilibrium. So what is the specific density of mass of body of mass m? So this is the body whose mass is m. What is the specific density of body of mass m, so that whole system is in equilibrium? What is the specific density of, now weight of water and bucket water and bucket, weight of water and bucket is w. So if weight of liquid and bucket is w, what is the specific density of the body, this body? And the system is in equilibrium. So to find the diagram, to solve this problem, we have to draw the free body diagram. So here this and this. So first, if what is the force acting on this bob? Here mg acts in this direction, buoyancy force acts in this direction. This is the buoyancy force act in this direction, and tension of the string in this direction. So for equilibrium, here T plus B equal to mg we can write. This is equation 1. Now here tension of the string is act in this direction, and what weight of the W, suppose W is total weight, and buoyancy force act in this term is important. Here we know the buoyancy force act on the body, but if the liquid exert the force B, then the liquid also, if the liquid exert the buoyancy force B, then a reaction force comes. The reaction force on the liquid comes, the reaction force exert on the liquid. Now that force act on the bottom of the bucket. So if this buoyancy force B act on the small body, then reaction buoyancy force act on the bottom of the surface, bottom of the bucket. So this condition is T equal to B plus W. This is equation 2. Now if we put T equal to B plus W plus B equal to mg, so 2B plus W equal to mg. So buoyancy force, what is buoyancy force? Buoyancy force equal to volume mass by density of the solid, specific density of the solid, and buoyancy density of the water, VdG plus W equal to mg. So now 2 mg density of the solid by density of the water, ds by dw. This part is, from this part we get ds by dw, we get density of the specific density, which is equal to d specific density d. Suppose specific density is d. So d into g equal plus w equal to mg. So d equal to mg minus w, this. So d equal to 2 mg by mg minus w. Minus w. So this is the answer. This is the answer. This is the answer. W by S. W. If the system is in equilibrium, then we draw the free body diagram of each part. Then we write this equation. We get the density of the specific density, means density of the body to the density of the water. This is specific density. So we get this result.